Hello, this is part of my video series on basic statistics. This should enhance your application of statistical knowledge or preparation for statistical exam. You are advised to pause the video to study the slide. I've made the slide comprehensive enough. What we'll be looking at today is design and analysis of sampling. To help us understand this, we'll consider an example. This is for a case where we have a finite population. A finite population of 350 measurements has a mean of 1050 and a standard deviation of 150. A random sample of size n equals to 9 is drawn from the population, and we want to determine the mean of the sampling distribution of the sample means, the standard deviation of the sampling distribution, and by extension describe the shape of the distribution of the sample means. So the first thing to do is to identify the parameters given in the question. We have been given the population size, the population sample, the population mean, the population standard deviation, and the sample size. And since we have a finite population, we therefore include the finite population correction factor. So by central limit theorem, the mean of the sampling distribution is equivalent to the population mean, and that is equivalent to the 1050. So by interpretation, if all possible sample of means is considered, and we take the mean of all the means of the samples, it will be approximately 1050. And then the standard deviation of the sample means will be equivalent to the population standard deviation divided by the square root of sample size multiplied by the square root of the population size minus sample size over population size minus 1. The square root of the square root of population size minus sample size divided by population size minus 1 is called the finite population correction factor. So by the time we substitute the values, we see that the standard deviation of the mean will be equivalent to 49.43. So now that we have the mean, we can therefore conclude that the sample means follow a normal distribution with mean of 1050 and a standard deviation of 49.43. So the shape, therefore, according to central limit theorem, says the population shape would also play a descriptive role for the sample distribution. So therefore, since the population, if the population is normally distributed, the mean of the samples will also be normally distributed. On the other hand, if the population distribution is unknown, the distribution or the shape of the sample means will also be unknown. If you find this video helpful, like, share, and comment in the comment section. Thank you.